Okay, so in this video we're going to talk about combining uncertainties. In the previous videos we've looked at how we actually get the uncertainties. But what happens when we've got multiple values that have uncertainties that then contribute towards a final? So say, we're going to go through an example in a second about that kind of scenario like that. So practical you've already done probably by now watching this video is the maybe a car down a ramp video. Practical, apologies. So in a car down a ramp you might, for example, measure the distance between two light gates, for example, and then measure the instantaneous velocity at a point here. Call that V. And we've got distance S. And we've got an initial velocity of U. So well done if you guessed it. We've got SUVAC problem coming up. So let's go with a value, let's say 0.530 meters per second. And we've got a distance of, or displacement of 3 meters. And we want to work out what the acceleration down the ramp is. So the acceleration down this ramp, we're going to use SUVAT, so SUVAT. Let's just do this really quickly. 0.530. Acceleration, what we want to find out. Not interested in time. So I'm going to use V squared equals U squared plus 2AS. We can get rid of that because it's 0. So we end up with A is equal to V squared over 2S. We can then plumb those numbers in, 0.53 squared over 2 times 3. And if we work that out, is 0.047. So 0.047. So you might be thinking, well, he hasn't done any uncertainty yet. Well, yeah, we haven't because we need to have a value to do our uncertainties around. So we've just made up those values and we're going to use them here in a second. So we've got a value for SUVAT. Remember, if you're not happy with this SUVAT, do go back and look at some SUVAT questions. Try not to spend too much time on this one because I have just sped through it. Right, so we've got our final acceleration of 0.047 meters per second. Now I want to work out an uncertainty in my acceleration. So we've made a couple of measurements. We've measured the 3 meters. We've measured a final velocity. Okay, now we need to take care here, because I'm just essentially going to make up the uncertainty for the velocity. You could break up the velocity into distance and time for that point, however your light gate's working, and work it out separately, but for all intents and purposes here, I'm just going to assume that I know the uncertainty, okay, ahead of schedule. So the uncertainty for a 3 meters is 1 millimeter because we're using a standard ruler. We wouldn't expect to use anything different. So we're using plus or minus 1 millimeter. So 1 times 10 to the minus 3 meters. Then for this one, I've just made up a value. So plus or minus 0.016 meters per second. Okay? So 0.016 meters per second. So you should now be able to go and work out, if you've watched the first video, what the percentage uncertainties in each of these measurements are. Okay, so the percentage uncertainty here is 1 times 10 to the minus 3 divided by 3 times 100. Percentage uncertainty here, 0.016 divided by 0.53 times 100. So in both cases you should get answers of around 3% for So 3%, 3% is this one, apologies. 3% for this one, and we should get about 0.03% for this one. Okay, so I'm actually going to use this to the proper amount of decimal places, 0.02 I believe it is. Yeah. Now notice I'm using the same precision all the way through as much as possible, 2 decimal places, 2 decimal places. We can go up to 3 there, but we will go up to 3 when we get our final value. So what we're looking at here is we've got 2 percentage uncertainties. So what do I do with these? What do I do with these? Well, here's a hard and fast rule for your notes. Always, 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 always add them. You're not going to do anything else to percentages apart from add them. You never take them away, you never minus them, you never times them, you never divide them. You always, always plus them together. Now, how we plus them together is a different matter altogether. Now, we need to return to the equation that we used to work out the acceleration. So the acceleration was equal to velocity squared over 2s. So let's look at each of these values individually. So s, well, that's got an uncertainty of 0.03. So we've got 0.03 plus v. V's got a percentage uncertainty of 3.02. Okay, so we add that on. Now there's something else that has an uncertainty here. See if you can guess what it is. Have you guessed? Right. For those of you who've worked it out, v squared technically means v times v, which means there's 2 v's in this calculation. So we should have 3.02 again. So for every time a term is in an equation, you will add the percentage uncertainty together. So in this case, we've got 6.02, 6.04, 6.07. So to put total percentage uncertainty is 6.07%. And we've got final, now, percentage uncertainty of my acceleration. So what am I going to do with it? I need to have a look at what that percentage means as a percentage of this. So, how do I do that calculation? Well, we know, we'll do the algebra properly, like as we would normally do it. We know that the value, or the smallest of the thing that we're looking at, divided by the value times by 100, will give us a percentage. Well, this time we've got the percentage and what it's divided by, but we need the value on top. So we're looking for this one. We've got our 0.047. And we've got times by 100 is going to equal that 6.07%. So let's think about this strategically here. So first of all, we're going to divide by 100 on both sides. So that's going to take us, we're going to divide by 100, and then we're going to times both sides by 0.047. So if I was to rewrite all this out as we would expect, we'd have 6.07 divided by 100 and then times by 0.047. And that is going to equal our plus or minus value. So when we work that out, we should be getting 6.07. So I've got a percentage uncertainty of 0.002852. Obviously I'm going to round up to our smallest percentage, our greatest precision. Now remember, I wrote a 0 there for a reason. So we've got 3 decimal places we're looking for, so we're going to round that up to 0.03. So we're going to get 0.003 meters per second to the minus 2. Now that means, overall, that our acceleration is plus or minus 0.003 meters per second to the minus 2. Suggesting that the value for my acceleration for the experiment I showed you could be anything from 0.050 to 0.044. Okay, so I've worked out an uncertainty based on combining values and seeing what we can get as a result of that. So, when you do some practical experiments, having a go at those methods is really, really important. Getting practice of them and working them out. We'll do some examples in class anyway, and no doubt some of you will have questions for me. Feel free to post them at the bottom of this video. I'll answer as many as I can, or save them for class, write them on your notes, and we'll deal with them there and then. Thanks.